Hello everyone, welcome to Eduxcite classes. In today's session, we will start topic 12 and the last series of this particular playlist. Okay, so without wasting time, let us start with the very first question. So the very first question is very basic. It is based on the photoelectric effect, which is one of the most common topic from this topic 12. The photoelectric involves the emission of electrons from. So we know that when a light is incidenting on a metal surface or on a photo surface, if the frequency is greater than the threshold frequency or the critical frequency, then there is an emission of electron from the surface, not from the interior. So you can say it is from the surface of metal with the help of electromagnetic radiation. So rest all are incorrect. Now the work function, I hope everybody knows about the work function. It is nothing but the minimum amount of energy required for the electron to escape from the surface of the metal surface. Okay, so this is the minimum. Wavelength incorrect, frequency incorrect. Now look at option C and D. To cause photoelectric from interior, not from the interior, it is just from the surface. So option C is the right answer. Now question number 3. When a light is incident on a metal surface, electron may be ejected. The following graph shows the variation of frequency with maximum kinetic energy of the ejected electrons. So which of the following graph best shows the variation of frequency of the maximum kinetic energy of the ejected electron if another metal surface, now this is very important, and another metal surface with a lower threshold frequency is used. Now if the threshold frequency is less, it means the emission will take place at a lesser frequency. So the graph will start more towards the left hand side as per the given graph. So this is the same, which is incorrect. This is also the same, which is incorrect. Now we have to think in option B and D. Now look at the slope. There will be no change in the increase in the kinetic energy, because once the energy is being utilized for the work function, the remaining will be the kinetic energy, and the frequency and kinetic energy are directly proportional. So option B will be the right answer. There will be no change in the gradient of the increase in the kinetic energy. Okay. Question number 4 now. A light incident on a clean metal surface produces photoelectron, which is given to us. The threshold frequency of the light is determined by. Now the threshold frequency is only and only is the factor of the nature of the photo material or the surface on which the light is being incident. It is independent on any other factor. It is just depend on the nature of the material on which the light is being incident. Okay, so the nature of the metal surface, option C. Question number 5. In experiment to investigate the photoelectric effect, a monochromatic light is incident on a metal surface. The photocurrent and maximum kinetic energy of the photoelectrons are measured. This is a very good question. Please pay attention. Which one of the following correctly shows the change, if any, in the photoelectric current, okay, and in the maximum kinetic energy of the photoelectron when light of the same intensity but higher frequency is incident on the same metal surface? So when we are keeping the metal surface as the same, there is no change in the work function. Now they are saying what change should be there in the photoelectric current and the maximum kinetic energy, but the light has the same intensity but higher frequency. So more the frequency of, this is for the same metal, okay, so more the frequency, more will be the maximum kinetic energy. So let us first look. No change, incorrect. Decreases, incorrect. Now we have to think in terms of B and D. This is the best way to eliminate the option. Specifically in your paper 1, try to eliminate the option so that you can think in a right direction. Okay, now we have to think in B and D. Now D says no change in the photoelectric current and B says decreases. Now majority of the student may get confused when you will be understanding the concept of photoelectric effect, that intensity plays no role, okay, when the frequency is changed and at the same intensity the number of photoelectron will not change, but that is not correct. The reason being, if frequency is increased, then we can say E is equals to hf. This is the energy of a one photon. So if frequency increases, the energy of each photon increases, and we know that one of the universal law of conservation of energy says that energy is conserved. So whatever the energy is being incident on the electrons, the electron will get that maximum amount of energy, but fewer electrons will now be able to emit out from the metal surface. I repeat, if energy is increased and the energy that is incident has fixed number of photons, okay, so what will happen in that case? The energy that will be absorbed by few electrons only, because of the increase in the energy. Therefore the energy increases of the photon, okay, because of increase in the frequency, the net energy that will be available will take only few electrons out from the metal surface. So if few electrons are emitted out, then the photoelectrons will decrease, okay. So the photoelectric, if the electron decreases, then the photoelectric current will also decrease. So option B is the right answer. Do not get confused, guys, okay. So in case if you have any doubt, you can comment below. I will try my level best to clear all your doubts, okay. Now question number 6. Now the question says, when electrons of suitable energy travel through a thin layer of graphite, this is a thin layer of graphite, this is the pattern of the concentric circles are formed on the screen. The production of this pattern is evidence for, we know that this is nothing but the wave nature, because this is what diffraction of the electron is taking place. So you can say the wave nature of the electron, the nuclear model of the atom, the particulate nature of the electron, the existence of. So this is nothing but gives us the evidence that wave nature of electron is there. Now de Broglie wavelength is everybody knows, lambda is equals to h upon p, okay, and this matter is associated with all types of particle, that is nothing but the dual nature of matter, which suggests that each and every particle shows their dual nature, the wave nature as well as the particle nature. So it is not an exception that it will only be possible for electron or a charged particle or a neutral particle. It is possible for all the particles. Okay, now question number 8. Which of the following phenomena provides the evidence of de Broglie hypothesis? Now we know that de Broglie hypothesis gives us the evidence nothing but the electron diffraction. Due to that diffraction only we are able to find out the wave nature of the electron, and that was further we classified the wavelength as h upon p, where p is the momentum, lambda is the wavelength of the wave nature of the electron which is orbiting in a particular orbit. De Broglie wavelength that has kinetic energy Ek is lambda. What is the wavelength is proportional to? Now this is very common, guys. This is h upon p is equals to lambda, okay, and we know that kinetic energy is half mv square. So if I multiply m on this side, you can say it becomes mv whole square upon 2m is equals to kinetic energy, okay. So mv is nothing but p, so you can say p square is equals to 2m into Ek, and so you can replace a lambda is equals to h upon under root of 2m E into k. So rest all are cancelled, this is constant, this is all constant. So you can say lambda is proportional to 1 upon under root of kinetic energy, which is option C, okay. Now question number 10. Which of the following best shows the variation with kinetic energy E of the de Broglie wavelength lambda associated with the particle? So right now we get the relation, it is inversely proportional to root Ek. So I think inversely proportional is this one only. So B is the right option, okay. Question number 11 now. An electron of mass m e and proton of mass m p are moving with same speed, okay. The speed is same. The de Broglie wavelength, so lambda is equals to h upon mv. So v is same, so we can say lambda is inversely proportional to m. So we have to find out lambda p. So lambda p will be 1 upon mass of proton, lambda e will be mass of electron. So it simply is equals to mass of electron over mass of proton, option B. Easy. You have to remember this formula, lambda is equals to h upon mv. Mv is nothing but the momentum. This is nothing but the de Broglie wavelength, okay. It was suggested by the scientist de Broglie. So question number 12 now. A beam of electron is uniquely defined wavelength lambda is incident on aperture of height d, and electron beam is passing horizontally. Okay, now there are three directions. The beam is traveling along the x direction before it passes through the small opening d. The height d is of the same order of lambda. So this gives us the information that this electron will get diffract. So after passing through the aperture, the component of momentum in x is px and the momentum in z is pz. Which of the following shows the uncertainty in px and the pz? Now I know many of you might be having doubt in this question. So the best answer for this will be, you can understand that initially it was there in the x direction. So we know that it will diffract from x into different direction, and the momentum in x and z are given to us. We have to find out the uncertainty. Now we cannot be sure of both the uncertainty is 0, so option A is incorrect. Both will be having h upon 4 pi d, that is also incorrect. So you know that delta x over delta p is greater than equals to h upon 4 pi. Now in this case, the diffraction case, you should remember this, that initially it was in x direction, so we can be assured that the uncertainty in the x direction might be 0, but for that in the z direction it has to be h upon 4 pi d. We cannot take this because we are sure it is initially moving in the x direction. So in the x direction we can say that the uncertainty is 0, but provided that the uncertainty in the z is this much. So option C is not correct, option B is the right answer. Okay, so that is I can best explain to you. Even though if you have doubt, just comment below, I will try my level best to explain. Okay, now the 12.2, the nucleophysics one. Question number 1, which of the following best shows a possible path of alpha particle when it is deflected by a stationary gold nucleus? So we know that this is very quite easy. Alpha particle being a positively charged, nucleus is also being a positively charged, they will repel, but the order of repulsion will be the B1. It is not, it is very far away, so it will move straight. So A is not the right answer. The repulsion is taking place at this point, this is not the correct. And D is saying that it is have a sharp repulsion, but it is a gradual repulsion will takes place, so that is also not correct. So option B is the right answer. Okay, now question number 2, the diameter of a nucleus may be estimated from. So we know that the diameter of any nucleus we can estimate in the alpha particle scattering experiment, that is nothing but the charged particle scattering experiment. Okay. Okay, now question number 3, the which one of the following gives evidence for the existence of nuclear energy level? So when we are talking about nuclear energy level, the most prominent evidence for that is nothing but the gamma ray spectra. So when we got the photons, when it is decaying from the gamma radiation, we got the different energy levels of those particular radiation when it is coming out. It is a particular discrete value. So this gives us the evidence of nuclear energy level. Now question number 4, which of the following correctly describe the nature of energy spectra of all the alpha, beta and gamma radiation? So we know that alpha being a nucleus of a helium atom, when it moves out from a nuclei, it changes into a daughter nuclei, and there is a specific difference in the energy level. So it always have a discrete values. So the radiation or the spectra will be a discrete for the alpha. Now when we go for the beta one, beta is nothing but either beta plus or beta minus. So a proton is converting into a neutron, or a neutron is converting into a proton. So in that case we get a continuum range of the energies. So this is continuous. Okay, that is correct. And when we consider the gamma, as I discussed in the last question, this also gives us the discrete, because when the photon is emitted during the gamma radiations, they get a discrete value of the energies, because E is equals to HF. Okay, so that is nothing but the difference in the energy levels in the nucleus. So that is again discrete. So option A is the right answer. Always remember, alpha is discrete, beta is continuous, and gamma is also discrete energy spectrum. Now question number 5, the spectrum of energy of beta minus. Now when a beta minus is taking place, let us say this is the parent nuclei. So this will be A and this will be beta minus. So electron, so this will be plus. So what happens in this is, in beta minus, an electron is, so a neutron is converting into a proton and electron. So electron is being emitted out, proton reside inside the nucleus. So proton number increases by 1 and electron is being emitted with a very important, with the emission of electron anti-neutrino. This is anti-electron neutrino. Okay. So option emission of anti-neutron during the decay process gives the explanation of the beta minus particle. Okay. Similarly, in question number 6, if you look at this question, there is a potassium of 40 at a ground state decays to excited state of nucleus argon 39. The argon 39 then reaches its ground state by a gamma. So this is gamma. The diagram represents beta plus and gamma energy level. Now with this is beta plus. So in beta plus, what happens again? The reaction will be like this: beta minus, a proton is converting into a neutron and emission of positron. So this is positron with neutrino. So the particle X is nothing but a neutrino. Option B is the right answer. Okay. So you have to remember, guys, this is very important from this particular topic, the beta plus and the beta minus. So the general equation you should know. With positron, a neutrino is emitted, with electron and anti-neutrino is being emitted. So this is very important. Now question number 7, which of the following is correct definition of the decay constant, which is nothing but lambda. So this everybody knows that, and lambda is nothing but the constant of proportionality linking decay rate to a number of undecayed nuclei. So you can say that this is, I think, is given in your data booklet also, minus dn by dt is equals to lambda, okay, n, or minus of lambda n, you can write like this also. Okay. Okay, now question number 8, the decay constant of two nuclei is lambda. One nucleus decay with a time interval within a time interval of 1 second. The probability of decay of other nuclei in the same interval will be. So there is no change, it will be the lambda only. Okay, there is no change. The decay constant of both of them is lambda. So this is not probability of decay of other nuclei in the same time interval. Decay per unit time is nothing but the decay constant only. Okay. Question number 9, the half-life of a radioactive is 1 into 10 raised to power 3 second. So this is T half is given to us 1 into 10 raised to power 3 in second. What is the probability of the decay per second of a nucleus of the nuclide coated to one significant digit? So decay constant is nothing but, if you know the relation of T half-life, that T half-life is equals to ln2 upon lambda. Also lambda will be ln2 upon T half. ln2 is approximately 0.693 upon T half is 1 into 10 raised to power 3. So this can be written as 0.7 into 10 raised to power minus 3 or 7 into 10 raised to power minus 4. So option A. So you should know that ln2 is approximately equals to 0.7 because the calci is not allowed, or even if you look at the just the order of magnitude, if you look, you can get the answer A. Okay, so that's not a problem. Now question number 10, this is very important. A decay constant of lambda of nuclide with a long half-life, pay attention to this particular long half-life, may be determined using the equation this. Now which of the following is the best explanation to why this equation may be used? So we know that if T half is more than ln2 by lambda, so if T half is, it's a very long half-life, so lambda has to be very less. Lambda here represent the decay constant. Okay, so if decay lambda is very low, we know the number of nuclei present is a constant. It depends on the radioactive material that you are considering. So if this is constant, it has no role. So if lambda is less, so activity will also decrease. So if you look at the option, the activity of the sample decreases slowly. That is the only correct. That is the reason why this equation can be used. Okay, rest all are incorrect, you can check. Now question number 11, which one of the following statement is true for the decay of a radioactive isotope? So for this question you should remember what is the definition of okay, now question number 11, Which one of the following statement is true for the decay of a radioactive isotope? So whenever we consider the radioactive isotope, this is all about the activity. Now what is this activity? Activity is nothing but it is proportional to the number of nuclei of the isotope present at that time. It is not this, not this, not this. Just read the statement very carefully. This shows that at any particular time is proportional to the original number of nuclei present. It is not responsible. Activity is depending on at that particular time. Okay, this is incorrect. This is also incorrect. So option B is the right answer. Even though if you have doubt, you just comment below. I will try my level best. Or if you have any, if you need any private tuition needs, you can call or contact me in the description, or you might find the contacts below. Okay. Now question number 12. Which of the following graph shows the variation with mass m of the activity of a sample of a radioactive material? Now we know that as the material increases, okay, activity is equals to lambda n, and as the number of nuclei present increases, the mass increases, and the mass increases, then the activity will also increase. So option B will be the right answer. Okay. Now question number 13. An initial activity of a sample of a radioactive isotope of half-life is given to us as 10 hour is A. What is the age of the sample when its activity is 1 by A by 32? So it's very simple. You just go with the sequence A, then A by 2 is the 1 half-life, then A by 2 to A by 4 will be the second half-life, then A by 8 third half-life, A by 16 4 half-lives, number of half-life is 4, then A by 32, which is the fifth half-life. So from A to reaching A by 32, 5 times the half-life. So 5 into half-life is 10 hours, so that will be, the age will be 50 hours. Option C is the right answer. Okay. Now the last question of this series, the playlist which I have created long back. I tried my level best to cover all the topics, and here comes the last question. The activity of the sample iodine 131 is plotted as a function of time with the logarithmic scale. Do not get confused. This is a logarithmic scale, activity in becquerel, and times are given in per days. So the half-life. So we know that half-life you can consider just by roughly looking at, this is 1000, so this is 5000. So if you zoom it in, this is how many days? This will be 10, so this will be 5. So this is 5, then just looking at the value, this is 10,000 and then 5000, so this will be 5. So this is 5, 6, 7, 8. So something around 8 approximately. So just to check, this is 8 days here. Okay, now 5000 to the half will be 250. So this will be 1, 2, 3, 4, 5. So this is this point. So this is 10, this is 15. So 2001, 1, 2, 3, 4, 5. This point. This point. So this is 15, 16, 17 approximately it is coming. So 17 minus 8 is again 9 approximately, 8 and 9. This is 8 greater than 8, and you can see this is just approximately 17. So approximately this is also coming as 8. So you can check for the other datas also. So approximately the half-life is coming out to be 8 days. You just check the half of each becquerel activity and how many days it takes place. So you can find out roughly it is equals to 8 days. Okay. So here we come to end of your paper 1 series. Okay. Now if you want other papers solution or the paper 2 solution topic wise, please support my journey, comment below. This gives me a motivation to continue with the work. I will try my level best to start with the paper 2 series soon. Okay. So wish you all the very best. Keep learning. See you in the next video.